friends, welcome to BSS Studies. I am Bala. Today I will explain about work and energy. Work and energy. This topic from physics. Okay? Here, work and energy. New lesson, and we have to know about first work. Okay? Work. Here, what is work? Work means if any object, I am taking this is an object, okay, mass, and if I push this object with force F and it displaces some distance, displacement. So that is, this case is called work. Work means work is said to be done when force is applied on an object and it should displace. Here work is said to be done when force is applied on an object and it should displace. When a force is applied on an object, it should displace. This case is called work. Here work means work is equals to force into displacement. Force dot displacement. Because these two are vectors, we should do dot product. So the formula of work is force into displacement. Okay? So here work means work is said to be done when force is applied on an object and it should displace. Force is applied to object and it should displace some distance. Okay? So this is work. Work formula is work is equals to force into displacement. Okay? Here work is directly proportional to force and displacement. Here work is directly proportional to force and displacement because when force is applied, it should displace. So that case is called work. So here work is directly proportional to force and work is directly proportional to displacement. So work is equals to force dot displacement. Because these two are vectors, we should do dot product. Okay? Here very important point, work is directly proportional to force and displacement because when force is applied, it should displace. So these two are proportional to work. Okay? So work is equals to force into displacement. Okay? Conditions. Here there are three conditions to apply work. So here there should be force applied, and second one, there should be displacement, and here there are three conditions. First one, there should be force applied. Here force is applied to any object to displace. So here there should be displacement. Here when work is done, there should be a displacement. Automatically a body when displaces, when force is applied only. Okay? When an object displaces, force is applied automatically. So very important point, second one, there should be a displacement. There should be displacement, very important. When there is displacement, there is force, because when force is applied, displacement is there. Okay? So displacement is very important. Okay? Here very important point, there should be displacement. Here when there is a displacement, automatically force is applied. When force is applied in a body, on a body, it should displace. So when displacement is there, automatically force is applied. When force is there, displacement should be there in work done. Okay? Units. Here work units. Here work formula is work is equals to force dot displacement. Okay? So in this SI unit of force is Newton. SI unit of displacement meter. Here work is equals to force into displacement. So in this SI unit of force is Newton and SI unit of displacement is meter. Okay? So Newton meter is the SI unit. In this kg meter per second square into meter. Okay? Here Newton means kg meter per second square into meter, Newton meter. So here kg meter per second square. Meter square per second square means this is Newton. Newton is equals to kg meter per second square, and here kg meter square per second square means joule. Okay? So SI unit of work is joule. Okay? Here Newton is equals to kg meter per second square, and displacement is multiplied because force into displacement. So kg meter per second square into meter is equals to kg meter square per second square. This unit is joule. Okay? So the SI unit of work is joule. Okay? So CGS of unit of force, dyne, and the displacement is centimeter. Okay? So in this dyne is gram centimeter per second square. Okay? And into centimeter, because we have to multiply centimeter. So gram centimeter square per second square. Here dyne means gram centimeter per second square into centimeter means gram centimeter square per second square. So this unit is erg. Okay? This unit is erg. And CGS unit of work is erg. Okay? So this is the derivation of joule and erg. In this, SI unit is Newton meter or joule. these two we have to use. So in this CGS, dian centimeter or erg. Okay. In SI, Newton meter or joule. In CGS, dian centimeter or erg. Okay. So in this, the relation between these two units. Relation between joule and erg. Okay. So in this, 1 kg meter square per second square. Joule means 1 kg meter square per second square. Here I will write, see, joule is equals to kg meter square per second square. Erg is equals to gram centimeter square per second square. Okay. So here 1 kg means 1000 grams. 1000 grams. Meter square is equals to, here 1 meter square is equals to 1 meter into 1 meter. Means here 1 meter means 100 centimeters. 100 into 100, 10,000. 10,000 centimeter square. Okay. 1 meter square is equals to 10,000 centimeter square. So here into 10,000 centimeter square per second square, because time is same unit. CGS or SI unit, time is same units. Okay. So in this, 1 kg meter square per second square means 1000 grams into 10,000 centimeter square per second square. So in this, 1000 into 10,000 means 10 power 7, because very simple method. Here 3 zeros, here 4 zeros, means 10 power 7. Okay. 10 power 7 gram centimeter square per second square. Okay. So here 1 joule is equals to 10 power 7 erg. Okay. Here 1 kg meter per second square is equals to 1000 grams into 10,000 centimeter square per second square. Here 1 kg is equals to 1000 grams and 1 meter per second, 1 meter square is equals to 10,000 centimeter square per second square. Okay. So here 1 joule is equals to 10 power 7 erg. Okay. So these are the units and relation. Types of work done. Types of work done. Okay. In this there are 3 types of work done. First one, positive work done. Positive work done. Here when positive work done is done, when force and displacement are in same direction. Same direction. Here when positive work is done means force and displacement are in same direction. Here this is ground, this is ground, and here one of the object is there, and I am pushed some force. I am force applied on this object and it displaces some distance, some displacement. Okay. Here force is also in direction and displacement is also in direction only. So these are same direction. So positive work done. Okay. When force and displacement are in same direction, positive work done is done. Okay. Second one, negative work. Negative work. Here when negative work done means when force and displacement are in opposite direction. When force and displacement are in opposite direction. When force and displacement are in opposite direction, negative work is done. Okay? Suppose I am taking, do you know wall? Well, like this will be there. Okay? Here one of the rod is there and here pulley. This is we have to pull like this to get water from this well. Okay? Here force is in direction. Okay? Force is in direction. Force is in direction and work is in direction. Displacement. In this well, force is in this direction downwards and displacement is in upwards. Because here when we force apply to like this, it displaces through upwards to get water. So these are in opposite direction. So well is a negative work. Okay? When force and displacement are in opposite direction, those two are in opposite direction. So those are negative work done. Okay? Well is negative work. Okay? So this is negative work. When force and displacement are in opposite, negative work is done. When force and displacement are in same direction, positive work is done. Okay? Third one, no work done or zero work. Zero work. Okay? Here there are so many cases for zero work done. Here when force is equals to 0, when force is 0 and displacement here, when force is 0, work is equals to force into displacement and 0 into displacement 0. Okay? Here when force is 0, work is 0. And second one, when displacement is 0, work is also 0. Because we are multiplying two quantities, force and displacement. So here 0 into displacement means 0. And here 0 into force means 0. Okay? So third type, third case, when these are perpendicular. Force is perpendicular to displacement like this. Here force is applying, force is like this and displacement is like this. Perpendicular to each other. When force and displacement are perpendicular to each other, zero work is done. Okay? So these are the three cases for no work or zero work. Here one of the example, if I push wall, displacement is 0 and work is done. Sorry, force is applied and force into 0 because there is no displacement on the wall. So force into 0, 0. 0 work done. Okay? So this is the work topic. Work means when work is done means when force is applied and it should displace. When force is applied, it should displace. That case is called work. And the conditions is there should be force and there should be displacement, and very important is displacement. When displacement is done, automatically force is applied. Okay? So unit, SI unit is joule and scissors unit is erg. Okay? there are three types of work: positive work, negative work, zero work. Okay. So problems on work. Problems on work. Okay.
Next topic.
First one, when a force of 100 dyne displaces a body through 25 kilometers, find the work done. In this question, when a force of 100 dyne, force is 100 dyne, okay, and displaces a body through 25 kilometers. Displacement is 25 kilometer, okay, and they are asking what is the work done. Work done means force into displacement. Okay, here force is 100 dyne. We have to convert into joule. So here relation is 1 joule is equals to 10 power 7 earth. Okay, so here we already learnt 1 Newton is equals to 10 power 5 dyne. Okay, we have to convert dyne from dyne to Newton. So 1 dyne is equals to 10 power minus 5 newtons, which means 1 by 10 power 5 newtons. Okay, so here if I take this in centimeters, for easily doing this I am taking in centimeters. So 1 kilometer is equals to 1000 meters. 1000 meters into centimeters means into 100. 1000 into 100, 1 lakh. So 25 lakhs. 25 into 10 power 5 easily. How many zeros are there? We should take to the power of 5. 10 to the power of 5. So 25 into 10 to the power of 5 into force 100 dynes. 100 dynes. Okay. So here 25 into 10 power 7 dyne centimeter. Okay. Here this is converted into centimeters, 25 lakh centimeters, and this is 100 dyne. We should multiply to get force. So 25 into 10 power 7 dyne centimeters. Dyne centimeters mean erg. Okay. So 25 into 10 power 7 erg. If we convert erg from erg to joule, we have to cancel 10 power 7, 10 power 7. Okay. So 25 joules is the work done. Okay. So next topic, energy. Energy we will continue next day. So this is today topic. ఈ వీడియో కనుక మీకు నచ్చినట్లయితే ప్లీజ్ లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి.